Okay, today we're going to talk about compound inequalities. There are two types of compound inequalities. One where you find the intersection of two inequalities, and the other is where you find the union of the inequalities. So we're going to start with the compound inequalities. So a compound inequality contains the word and is true only if both inequalities are true. This would be the intersection of both inequalities. Okay, so for example, so this is the first type of inequality, the intersection with the word and. Okay, so we have x is less than 3 and x is greater than or equal to negative 2. So the first thing I'm going to do is graph. We're going to do 3 graphs, one for each of the inequalities, and then the third one shows the intersection of the inequalities. Okay, I put the same numbers on all 3 graphs. Okay, so the first one is going to be x is less than 3. So we know it's an open circle, and we're going to shade to the left. Okay, the second one, x is greater than or equal to negative 2. So we go to negative 2. Now this one's closed because it's greater than or equal to, and it's greater than or equal to negative 2, so it's going to go here. Now that third graph is where we're going to combine the two, because end means intersection. What does it fall between? 2 and negative 2 and 3. So this would be your intersection. Now how do we write that? For all values of x, we have negative 2 is less than or equal to x, which is less than 3. So that would be this whole section in between my negative 2 and my 3. So for all values of x that fall between negative 2 and positive 3, including negative 2, would satisfy that inequality. Okay, now sometimes we them as compounds. So let's see if we have to pull this one apart. So this would be negative 5 is less than x minus 4, which is less than 2. Now this x minus 4 in the middle is not a single, it's not a single variable as it is here. It is an expression. So we need to break it apart first and solve it that way. So my first one would be negative 5 is less than x minus 4. And then I'd break it apart and put x minus 4 is less than 2. Now solve. So if I bring that over, I'm going to have negative 1 is less than x. So I can change that to x is greater than negative 1. I like to always lead with my variable. Here, it's going to be x is less than 6. I'm going to add 4 to both sides. And here I added a positive 4 to both sides. So here are my two inequalities with the word and in between. All right, so now when I graph these, again, I'm going to have 3 graphs. I'm going to try to keep the same numbers on there. So -1, I'm going to put that way over here. And you know these are all going to be values. I'm not going to fill those all in. And then x is less than 6, so we'll put the 0 here. And I'll put my -1 and my -1, and my 6 is going to be way over here. All right, so x is greater than -1. So here's my -1, open circle, and x is going to be represented by everything going to the right. The next one is x is less than 6, so here's my 6, open circle, everything shaded going to the left. So if we come down that graph, we know we have -1, and we know we have 6. So anything that falls in between, they share in common. So this would be, for all values of x, -1 is less than x, which is less than 6. Okay, so we use those two values as our boundaries or our perimeters. Okay. Now what about the one that has or? What about or? We could have a, this is going to be the second one. So the second compound, number 2, the second compound inequality contains the word or. Okay, so this is true if one or more of the inequalities are true. All right, so we could have a is greater than or equal to 10, or a is less than or equal to 8. Okay, so we'll do our solution set again. Do your 3 graphs. All right, so here's I'm going to put my 0 way over here. I'm going to put my 8, and I'll put my 10. All right, so A is going to be greater than or equal to 10. So greater than or equal to 10, it would be closed in, and it would go to the right. A is less than or equal to 8, so that would be closed in and going to the left. Now there's no intersection here because we didn't use the word and, it's the word or. So both of those would satisfy. So for both, okay, it's the union of the two. It's the union of the two. All right, so our answer would be, for all values of A is greater than or equal to 10, or A is less than or equal to 8. Okay, so that's when you have the word or, you're going to have 2 parts to the solution, not just one.